Assalamu alaikum guys, this is solid modeling using Inventor, lecture number 8. In this lecture we will start assemble parts. That means we will prepare the parts and now we will assemble them together to make a mechanism or machine or tool. So exercise number 1, we will make the assembly of the gate. As you see in this image here, we have the gate part designed already as a part file, each one individual file, and we want to assemble them together to make the assembly of the gate. Now at the beginning we have to go to new file. As I told you before, in the new file you have to select the units, English or metric. As example, we select metric here. These files for part files, surely I will not use them now because we already have the parts. These files for assembly, surely I will select one of them. We have mold design if you want to assemble parts to make a mold, and standard weldment. So weldment if you want to assemble the parts using welding. So for this classwork or this exercise, assembly number 1, we have to select standard millimeter assembly. I can select this one or this one, but different standard, that's it. So standard millimeter dot IAM. IAM means Inventor assembly. As you see, this is the user interface for the assembly. Still Inventor loading the assembly. Yes. Now at the beginning you have to collect all of these parts, the needed parts, and put them in one folder and keep them always with the assembly in one folder. And if you want to move the assembly, you have to move the parts with the assembly, and so on. I know where is these files because I already prepared all of the files. So I will go to place at the beginning. I will select my folder, say that I will go to the folder where we have the files, lecture number 8, assembly. We have the gate assembly. As you see, let me make view just to show you what I'm trying to do. See, this is the assembly, it's ready. This is the door file, this is the jack body file, this is the jack stem file, and this is the link file, and this is the pillar file. So let me select at the beginning the pillar. I will double click and select the pillar, click here, right click, OK. As you see, and in this user interface, it's like the part if you want to navigate. So you can use the orbit like this, you can go to the home anytime, you can go to the right, rotate like this or like that, anytime go back to the home. And also we have here two very important tools, the free move and the free rotate. It's not actual move, not actual rotate, it's just to prepare the part, to assemble it or mate it with other parts. Sometimes it's very difficult to assemble parts because we can't see the edge, it is in the back, or we have to prepare the part so it's near the assembly situation, so that we can easily select edges or faces to mate them together. So we can use free move and free rotate. Guys, at the beginning you should think the first part should be grounded or not. It's very important because grounded means fully constrained. It means 0 degree of freedom. We are talking about degrees of freedom. By the way, how we can, let me maximize the display. How we can, let me select this one and show you how we can move it. I will click. It is you can move in X direction, in Z direction, in Y direction, and easily move around the X, rotate around X and Y and Z. That means currently this part have has 6 degrees of freedom. When you add constraint, you will cancel one of these degrees of freedom. It depends on the constraint you added. Now, how can I show the degrees of freedom that this object have? We can go to view as example and go to here, degrees of freedom. Now it's not active. Now active. See this part can move in this direction, in this direction, in that direction. Can rotate around this direction, rotate around this direction, rotate around this direction. Okay. Now, as I told you, this part we should think the first part should be grounded or not. What meant by grounded? Fixed. That means 0 degree of freedom. It depends on the assembly you have. In our idea here, in our exercise, this part should be fixed. So what I will do, I will right click on the part and here I will select the grounded. Click on the grounded. Let me go back. See the icon on the mouse. It's converted to grounded. Right click. See, it's grounded, activated. That means this part fixed now. I'm trying to move it in Z direction, not moved. In X direction, not moving. In Y direction, not moving. Z direction, rotation, not rotated. It's fixed. 0 degree of freedom. Okay, now I will go to assembly and place the other component. Let me start by the door. Skip all, no need to do anything. Okay. I'll see how many doors you want to place. 1 is enough. Right click, okay. Now I know that I am the designer and I should know all details how to assemble the parts. So I know that these hinges, this cylinder, small pin, should go inside this hole, and this pin also should go inside this hole. At the same time, I will show you the face first. How can I rotate to show the face? I told you we can use the free rotate. By default, the door selected. We can rotate it like this to prepare it for the assembly. It's very good, and we can free move the part like this, just to show you how we can assemble it. Now making zoom in to show you again. I will see this pin should go here, this pin should go here. At the same time, this surface, this cylinder surface, should mate with this surface. So what I will do, I will add some constraint. So I will use constraint to assemble the parts. As you see, we have constraint, mate constraint. We have mate used for edges or surfaces, and flush used to mate surfaces also. The difference between mate and flush, as you see, the normal to the surface, in the two parts, they are opposite to each other in the mate. While in the flush, the normal to the surface for the two parts, they are parallel, as you see in the icon here. And we have also angle. We can use direct angle, we can use indirect angle or explicit reference vector to constrain the angle between two surfaces or two parts or two edges. It depends. We have also here tangent. You can constrain two cylindrical parts to be tangent together, or any parts, two parts to be tangent together. We have inside tangent, we have outside tangent. We have insert also. Actually, insert I will talk about later, to insert part in another part, and we have symmetry here. Let me go back to the mate. I want to mate. Mate. I will make zoom in. Mate the axis of this cylinder, small cylinder, to be mated with the axis of this hole. Apply, cancel. As you see, now the part can move in Z direction, but because the axis mated to the axis, we can't move it in X and Z direction. To show you that, let me go to the top view. See, I can't move it. I'm trying to move it to the left and right. No, I can't. I'm trying to move it up and down. I can't. But the object can rotate around the y-axis only. And also, if we go to front, I'll show you, it can move in the y direction. Now, to make it in the correct place, we have to constrain the movement in Y direction. How we can do that? So it can rotate around Y only, no movement on Y, just rotation around Y. I'll see here, this edge should be met with this edge, or this surface with this surface. So what I will do, I will prepare by free rotate the door like this, so I can see, just to show you, I can see this surface and this surface together, then I can mate them together. So I will add constraint, I will select mate, this surface and this surface, and the normals should be opposite to each other. Now done. Apply, cancel. Now let me check everything. It can rotate around Y axis, and this is correct. Let me go to the top view, show you it can't move in Z direction or X direction. Let me go to the front view, or this view or that view. You can select any one and go to the front like this to show you. I just see the door can't move in this direction or that direction, but can rotate around the Y direction. Let us go to the top view from here and go to this view. See, it can't move in Y direction, but can rotate around Y direction, and this is now correct. Now, next step, I will place another part. Say that I want to place the link, this link. Again, when you want to design, when you want to make assembly, you will finish the design first. That means you are the designer and you know all details about the assembly, about offset distances, about relative distances, about relative movement, how they will be assembled together. So we have all of the details. Now I know that this link should go here like this. So how we can assemble it? First of all, we have to free rotate like this, just to show you. This whole axis should mate with this whole axis, and this surface should mate with this surface. So it's very easy. We can constrain, doesn't matter which one is the first one. You can do the axis or the surface first, it's up to you. So I will make mate this surface to be mated with this surface, normals opposite to each other, like this. Apply, cancel, and then I can move it like this, guys, and then go back to constraint and select again mate, but this time axis to axis. Apply, cancel. Let me show you from the right side view. It will rotate, just rotate around the Y axis like this. At the same time, it's fixed at the correct position. If we go to the top view, see how it is rotate around this axis only. Okay. Next step, guys, we have to place the other part. Say that I want to place the jack body. Again, as I told you, because I am the designer, I know that how these parts should be assembled together. So I know that this cylindrical shape should go in this cylindrical hole, and at the same time surfaces mated together. So at the beginning, what I will do, I will free rotate. I will prepare this one like this. Okay, then I will move it like this and make zoom in to see. Now I want to free rotate also this part to see the surface. I'll see, we can see the surface now. This surface should mate with this surface as example, and the axis should mate with the axis, same idea. So I move to constraint. Let me constrain the surface to the surface like this. Apply, cancel, just to show you what happened. The surface mated to the surface, but the part can move. Now we have to fix the axis to axis. So constrain mate the axis of the cylinder to mate with the axis of the cylinder, apply, cancel. Now it's okay. Let me go to the top view to show you how the mechanism working. As you see, like this. And at the same time, let me go to the side, the other one better. Okay, show you. It moves like this. Now we have to place the jack stem, and jack stem should go inside the jack body and connect the door with the pillar. So I will select jack stem. I know, again, same idea, I know how to assemble them. I know, because I am the designer, I have all informations. I know that the jack stem, this part should be go inside here, inside this gap, and this part should be joined with this one. So I will free rotate to prepare it for the assembly, like this, better. Okay, so what I will do, I will constrain the axis of this one to go with the axis of this cylinder. Then apply, cancel, take it, move it like this. Now I will join. It's enough just to join axis of this hole to axis of this hole. Surely I have to use some screws or whatever, but this is just a demonstration. Constrain the axis of this hole with the axis of this hole, apply, cancel. Now if you move the door like this, see, it moves. So this is the correct assembly. Just I want to show you an alternative solution. Let me select, I want to go back and insert another door inside the pillar. That means I will use the constraint insert. Actually, insert, it's equivalent to mating surface to surface with axis to axis together. So you will do 2 steps in 1 step only. This is the only difference, and the result will be the same. So I will make it later because I want to add a constraint here just to drive the motion. Once I finish the drive the motion, I will go back and insert the door inside the pillar to show you how we can do it. But for now, forget it. I will do the following. Now guys, the assembly is ready. No need to add more constraints, but to demonstrate the motion using drive command, we have to add a constraint. That constraint can control the motion and show you the motion and restrictions in the motion for this machine or for this mechanism. As example, this door can go from here, as you see, like this. I wanted to make 90 angle only from here to here. So I will start this one. How can I move the door itself? I have to add a constraint. This constraint could be a distance. This constraint could be angle, whatever. As example, just to show you, example, this cylindrical shape should not go out from the jack body. The jack stem, this one head, should not go out from the jack body. As example, we can add a distance as a constraint, and this distance can vary from 0 to some distance. At the same time, when you change this distance, as example, this offset, when you change this offset, the door will move in and out. So if there is no conflict, we can do that. Let me constrain and select as example, I want to make a mate between this surface and this surface and make the offset distance 0. I think it will not work, but let me check. Apply, cancel. Now it's okay. Now distance is 0. But see, when distance is 0, the door will be like this. Now this distance is 0. Let me go back to the jack stem again and see. This is the mate, the last mate I added. Right click, edit again and see the offset distance is 0. I should know how much it should be. Say that 5, say that 10, sorry 10, make it 15 or 20. You can see as 20 it will be like this. It's just to demonstrate the motion. Now we can go to the mate, right click, drive the mate. As you see, this is the drive option. The start distance is 20. Let us make it from 20 to 80 as example. I don't know if it's 80 more than enough or not, but let me try and drive the motion. Very good. Anytime we can go back and make it here 120 as example. Make it 150 distance. Again, as a designer, you should know all of these details. Okay, let me show it from top view. We need more to make it 90 angle. Say that 158. Again and again and again. You are the designer. You should know all of these details. You have the numbers. Say it's okay like this, guys. Let me go back to the isometric view or 3D view. Okay, and now I want to record the motion to show you or demonstrate our design or motion in this design. Here we have recording. Record, press record, give it a name, say that Constrain number 1, door, Constrain. The file, you can record at AVI or Windows Media Video. Say AVI, save it. Okay, you have to select the compressor, select any one of them, no problem, not an issue. Now we will play. We finished everything. We can say okay. Now let me go and show you the file. Let me record again because I forgot where is the location of the file. So I will go back to the drive again, and say record. It is, yes, in the same. Okay. Let me go to show you. It's in the fall SMED by mistake. It's here. I think it's here. Yes, this is the video. It's by mistake come to here. Cut this video and paste it here. Okay, this is our video. As you see, so now let me go back to the Inventor and show you an alternative also here. As I told you, we can use, let me delete this mate. Again, we used a distance to demonstrate the motion. Let me delete this mate and go back to this situation. Okay, and how can I also make this movement or demonstrate the movement? If you go to the top view as example, as you see, when the door like this, there is an angle between this surface and this surface. There's an angle between this surface of the door and this surface or this surface of the pillar. So if the angle change from 0 as example to 90, it will rotate the door. So we can add an angle instead of the distance. So let me do it now. Let me go and select constraint, go to the angle, select the direct angle between two surfaces or two lines or two edges. Let me say that I want the angle between this surface and this surface to be 0 at the beginning. As you see, apply, cancel. Now I can't move anything because it's already fully constrained, and we have one additional constraint used to demonstrate the motion. So I think this is the constraint. No, this one, no. Let me go back to the door and check. Yes, this is the angle. Now I will right click on the angle, drive the motion. It is now 0. I will change it from 0 to 50 as example, and yes, but it is in the opposite direction. Let me say that, go back and make it -50 to see what will happen. Yes, but this is the opposite one. Let me delete this angle and do it again. If you remember, let me delete first. If you remember, it was like this. I selected this is the first one and this is the second one. I will do the opposite one. Constraint, angle, direct angle. I will select this one first and this one second. Apply, cancel. Now I will go to the angle, drive and select 90 and say like this. Just I change the order of selection. So it will be the door reference to the body or the pillar. I'm sorry for that. Cancel again, drive again from 0 to 90 degrees like this. Now let me delete this constraint. No need for this constraint. And as I told you, I want to show you how we can use insert. As example, let me delete this one. Let me delete this one. Let me delete this one again. Or keep them, no problem. Keep them, this one, keep this one, keep this one. But let me go to the jack stem mate. This one, keep it. This one, delete it, okay? Because I want to delete the door. Now I will select the door, delete the door, and I will bring the door again. I will go to place and select the door again. Place the door here, no problem. As I told you, you have to prepare the door like this. Okay. Move it to here. Now, guys, we can assemble the door with the pillar using constraint. I told you which constraint, the insert constraint. Actual insert, I want to insert this cylinder, but when you select the axis, don't select the axis only, select the edge you want to mate from here to there. So let me go back, constraint again, select, as you see, select insert. Okay, here I see opposite. Now I want to insert so that the axis will be mate with the axis, and also this edge mating with this edge. Once, apply, cancel. See, it's one step only. It's like axis to axis mating and then surface to surface mating, 2 steps in 1 step. Then you can go back here and constrain axis to axis, mate axis to axis, this axis to this axis. If you want to see the axis, you have to make zoom in, zoom out, and then do it like this. This is the first exercise, guys. I hope that everything clear. By the way, you have to save the file, and remember that this file should be in the same folder where you have the assembly parts. So for me, it's in the gate assembly folder. Keep all of the files, all of the part files, and the assembly, all related files for your drawing in one folder. And if you want to move one file, you have to move all of the files together so the assembly can open, because when you open the assembly, it will go to the original part file and take it from there. If the original part file not there, it will be missed in the assembly. Thank you so much.